Okay, for the next is the GTWR. It also have the similar concept with GWR. But in GTWR, there is a GWR model with a temporal meters. So in GWR, since they only consider about spatial, in here, GTWR account for both spatial and temporal, non-stationary in the same way. So the difference with GWR is extended with temporal effects, where the advantage it can capture the spatial and temporal variation simultaneously, and it also improves the model fitting. As we know, since GWR only consider one time frame, and they only can include the weights of variable within a specific distance, like nearby distance will have a given weight for only one time frame. So GWR limitation in here, they didn't include the weight in different time. It really matters when you have different time period of data. You can maybe use the monthly data, yearly data, or even daily data. If you use GWR, you maybe will merge all data into one time frame. But if you do that, maybe you cannot observe how the effect of your variable in different time, and you can only observe how the variable impact in different location only, and you merge the data in different time. So the solution of this methods is extending GWR to GTWR to simultaneously include space and time methods. The idea is GTWR calibrates the local regression models and borrowing data that nearby in both space and time. So same as GWR, it assume observation at nearby point. For example, in here is, sorry, this is the regression point, for example. They will assume nearby point J in here as the most influence variable since they have the shortest distance. They will find the nearest point based on spatial. But in GTWR, despite finding the neighbor in spatial, they also try to find the neighbor in different temporal or different time. So they will extend the search area into different time frame, not only in spatial frame, but they also extend the sample into different temporal time frame. So the transition from GWR to GTWR in mathematically, they only add the varying coefficient in different time. So instead having the same the different coefficient value in different area, GTWR will have a varying coefficients both in different locations and also in different time. But in here, the disadvantage of GTWR models in their weight matrix calculations are more complex since we include both spatial and temporal. So the estimation equations of GWR and GTWR remain the same, but only the weighting schema are different since we need to consider the temporal variable. This is how different approach in defining the weight matrix in GWR. The first approach that previous study do in defining the weight matrix is defining the spatial frame and the temporal frame differently. So they will calculate the how many samples that include in the spatial terms differently using the distance to spatial, and they also calculate the numbers of sample in different temporal time. Since the unit of spatial and temporal are different, in spatial we use meters, kilometers, and others, but in temporal we use time unit like seconds, minutes, and hours. Because the units are different, we cannot directly add them together. So they use different scale factors, and in the first study they used the ratio of tau to differentiate which ratio or which frame is more considered in calculating the weight matrix, whether we should go for more spatial or more temporal. The second approach from Fotheringham, they use different approach for calculating spatial and temporal weights. The first thing that they do is transforming the spatial distance and temporal distance into the kernel. So by using kernel, they avoid the dimensional reduction issues approach, and it doesn't force that meters and this into a single scales. But they still treat the spatial and time frame distinctly, but interacting these two dimensions by multiplying by using their kernel and got the weight functions. In here, the functions of the spatial and temporal component are quite different. In the standard GWR spatial kernel, they usually still use the Gaussian kernels, where calculate the spatial distance between point and j, they keep using meters and distance base. And the spatial bandwidth observation will specify for each time frame. And for the temporal component, they will calculate the distance between point I and j using time frame like seconds, as I mentioned, seconds, hours, and maybe after years. And in the end, they will multiply these two kernels together to get the spatial temporal weight. And to find the optimal bandwidth selections, same like MGWR, they can use both cross-validation value or AIC. But in here, most studies try to use cross-validations, where they try to find the minimum difference between the observed and predict value. So it quite takes time to run GWR, since it completely is intensive to calculate the optimum bandwidth, since they have two different terms in spatial and temporal. And to find a balance between spatial and temporal is quite challenging and takes some time to run. So you can see the flowchart, how they calculate the optimum bandwidth. They will try to fit the temporal and then the spatials, and they will calculate the overall CV value. If the CV value still large, they will back to set another value of temporal and spatial bandwidth until it get the smaller cross-validation value. There is some applications for GWR. In here, there's two studies, both are of them using house price. Since house price can change in both location and both over the time. So as we know, the house price in different area are different, and the house price in different years also different. So for this case, house price is one easy example to calculate GTWR. So they have two study cases in US and one in UK. In here, this is how we present or illustrate the house price and the coefficient value. In GWR, we only have one coefficient map like this, but in GTWR, we will have multiple year or multiple time frame coefficient map, and they will show how the coefficient map differ in 1 year to the other. For example, in here, in the oldest time, in here, for example, the floor area have a positive value with the house price. In central area of UK, you can see in here, the floor area impact the highest with the house price, which means the impact, the larger house area in the city center is much expensive compared the larger area of floor area in the suburban area or rural area. But in different time period, in the city centers, the impact of floor area getting higher compared to the previous year, which means that in this area, maybe they have some new regulation, maybe could increase the impact the floor area to the house price. And in the year of 1998, in whole area of UK, the floor area impact to the house price overall increase. So there is no yellow value, and almost in the central area, for example, they have the strongest impact. The floor area have the strongest impact to the house price, but still the pattern of the rural area have a lower impact compared to urban area. So that's how we interpret the GTWR model. And for the summary of this week lecture, for MGWR, it still improve the GWR model fitting by allowing the variable specific bandwidth and make it more flexible in capturing multi-scale spatial process. And MGWR is best to model spatial relationship when the independent variable is operate at different spatial scale, or we can say the independent independent variables have different impact in area. There's example of use like real estate pricings, like how the impact of house price nearby the schools or park. Maybe there's a regular trends like if there is a shopping mall just newly built in certain area, in certain those certain area usually have higher house price, so the proximity to the central business district will have larger scale effect. So in that case you can use MGWR. And for GTWR is best used for modeling spatial and temporal non-stationarity. When you have the spatial and temporal data, you can use GTWR. So the example use case is beside the house price, you can use for the air pollution studies, where the air pollution usually change over the place and also over the time. You can also evaluate the traffic safety analysis. You can predict the crash, since the crash also in, for example, in urban area is much larger and in the compared to rural area, and the crash frequency or crash value in different years also quite different. So that's all for today's class, and thank you for listening.